You can skip this section if you looked at video 1 in this series. Otherwise, I'll go over what we're looking at. And this is the different types of behavior modes that we're interested in modeling. And there's exponential growth, exponential decline, goal-seeking, S-shaped or logistics growth, overshoot and collapse, and oscillation. And the argument is that these behavior modes will show up in the actual data. And it may not be identical. It may be a combination of these different behavior modes that you're observing in your data. And when we're modeling, we want to know what type of structure will generate the different behavior modes. And this series of videos is going to show you what structure, or what very simple structure, will generate the different behavior modes. So this is a graph of exponential decline. Exponential decline simply means that the outflow rate is going to be proportional to the stock. And so that there's a connection or a first order control between the stock and the outflow rate. And in this case, you can see that it's just declining, and it's declining at a rate that's sort of less and less. And the reason it's less and less is because the stock is becoming smaller and smaller. Examples of exponential decline in the real world would be radioactive decay, and that there's a half-life, and it's gradually decaying, but there's less and less decaying. Another example would be depreciation of assets, oil reserves being depleted, or perhaps the body metabolizing a drug that's been ingested would be examples of exponential decline. And I'm just going to run through one example, and that will be next. I've opened a new model, and I'm ready to begin building my exponential decline model. And it's in month. I want to run this in days or day. So I'm going to click down and go to day. 0 is fine. I'm only going to run it out to 30. And my time step, I'm going to make smaller. I'll go with a 0.0625. I think I'm good with everything else. I'm going to click OK. And let me make this so you folks can see it. And now the first thing I'm going to do is I'm going to click on the stock, and I'm going to add a stock in here. So I have added my stock, and I'm going to call this radon. And radon is a gas that will decay, comes up from the ground. I'll click on my move. So I've got my grab on the handle and make my stock a little bit bigger. And there's going to be just an outflow to this stock. So I'm going to go up and click on my flow icon. I'm going to click once, right click once on radon 222, drag to the right, click one more time. And now I am going to type in my variable name, which is going to be called decay. Need to add one more variable, which is going to be the average half-life of radon. I'm just going to call it the average half-life. And now I'm going to go to my arrow key, and I'm going to double click on, or click once, on radon, go part way, click one more time, and then I'm just going to go to the variable name. There's a box around this, and I'm going to click on this. Let's see, can I tell this no for now? And click on this, and it's going to go to my decay, and I can go to my average half-life, click once, and tell it to click there. And now I have everything I need. If I go to f of x, I can see I have to write equations for this stuff. I'll start with the radon. It's minus decay. It knows it's an outflow, just the way I've drawn that flow in there. So I'm set with that. I'm going to go in and I'm going to start with 100. And the units here are going to be grams. Using the imperial system. Documentation, I'm going to save time and not put it in. I do recommend you folks doing that all the time. I'm going to click OK. I'll go to my average half-life. And I know that radon lasts 3.8 days before it decays. So the units here are going to be days or day. I'll click OK. And now I'm going to go into my decay and do the calculation for this. I know radon is in grams. I'm going to do the units first. Grams, and it's per day. So I know my equation, and I have the causes here. And the order here is going to matter because we are doing division, but it's going to be radon divided by the average half-life. And my unit should be correct, and I'm going to click OK. And I should be set here and capable of simulating at this point. Didn't do it in the last video. I want to go down and click on my check units. My units are okay. If I'd made a mistake, I would have gotten a unit warning error here. I'm going to make another graph. I know I want to drag this over a little bit so you folks can see what's going on. I'll go up to this icon here and click, and I want to go to Show Control Panel. Now I can make it larger. I want to go to Custom Graphs, New Graph, and I'm going to call this radon 222. Just going to copy this and use it. Radon graph. And I am going to, don't want to click OK yet. I'm going to go down into this, and I'm going to click on the plus and radon 222. I'll just look at my stock for now. Nothing's showing up because I haven't simulated yet. I'll click OK. I'm going to go up to my control panel, and I'm going to go to the workbench tool. Click over here on the left. Make it a custom graph. And go to radon 222 and close. Make this a little larger. And now I can go, whoops. I've added something and I didn't want to. I'll go to the delete button and hit delete. And now I'm going to go to the simulate button and run this. Please save. So one of the things that's going on too, you'll notice the last icon I clicked up in here, the last tool, it remains that tool. I want to make sure I go and click on the hand. I will save this. Save, and this is going to be exponential decay. Vensim. I'll click save. And now I'm going to click on simulate. That's okay. And you can see how I have the decay function here. One of the other things I want to do, I'm going to go and click on radon, edit. I would like this to be thicker. I'll go down and click on 3. I also want to add this in again. This is the current. Let me stop this and just click OK. I'll go up and highlight this and call this a base run. Okay, I'll hit simulate. Just going to run it again, and now I'm going to go to my graph and edit. And I'll put the data set in here. It's going to be base run. And then I'm going to click on the plus here to add radon one more time. Click OK. There's a button here, inherit scales, so it's going to be on the same scales. I'll click OK. And then I'm going to go to my equation one more time in the average half-life, and I want to go into simulate range. And I can't have 0 because that would generate division by 0 is what's going on. So let's say that it would be depleted in 1 day, and maybe I'll go up to 10 days, and I'll put this at 0.1 as my increment. I'll click OK, and now let's see. I want to change the base run. I'll call this current. I'll go to my dataset manager. I'll get rid of this current, and I have my current with capital up there. And now I can hit Synthesim, Yes, and you can see I have the two runs on this one graph, although it's hard to see because they're one on top of the other, and this one's pretty thin. So I'll go back to my custom, I'll go back to Data Manager, current's on top. That's exactly what I wanted. You want the current one to be on top. I'll go to my custom graphs, click on the graph, go to Edit, and here I'm going to click and make it 3 also. And now what I'm going to do, I'm still in Synthesim, so now I can change my half-life, and you can see how I have one graph, but I've got the same variable but with different data sets, so that I can compare my base run to if the average half-life increased, I'd end up with more radon, and if it decreased, I would end up with less. And I want to show you one more thing here, and I'm going to stop my Synthesim. And this average half-life, what I could do is take the reciprocal of this, right? So it's 3.8 days. Taking the reciprocal simply means I'm going to divide that 3.8 days into 1, and this would turn it into a fraction. So I'm going to go to f of x and click on this. And I know if I divide 3.8 into 1, it's approximately 0.26. I'll click OK. And this is going to be the fractional decay of radon now. I'm going to change that variable name. I'm going to click on my variable and come here. And this is going to be the fractional daily decay of radon. And I'm not even going to put the 222 on there. Whoops. I want to get rid of half-life. I hit the delete key and I was thinking of deleting the variable. So I've renamed this. And one other thing I have to do is, because I have made this reciprocal, I got to change the equation in here, right? I go up to f of x. I'm no longer dividing. Because it's a fraction, I am going to multiply. Hit the time sign. And I know I have one other thing. If I check the units, I know this unit's going to be incorrect. Go down here to the left and units check. I have a unit error. And when I was dividing, it was okay to be by day. But now that I'm multiplying, it's really dimensionless, or a fraction per day. So if I click on this and go up, I'm going to go to my dimensionless, and then it's per day. I'm going to click OK. Let me double check my units. Unit check. Units are now OK. And I'm going to simulate one more time. So I'm going to hit the Synthesim. Now my current is going to change so that it should go back to the default. And this is going to be 0.26 multiplied by, and I am anticipating, and this is sort of important too, right? Before you simulate, you'll always want to ask, what do I think is going to happen? We're testing our mental models. So I'm going to hit the simulate button and click OK. Oh, the range has changed because it's less than 1. But these two lines are actually on top of each other right now. I'm going to do one more thing. I'm going to click on my equation and click on this and go to my simulation range. And I can multiply by 0 now, right? And let me go up to 0.5, and I'll go up by 0.01. And I'm good. I'm going to click OK. Now I'll click on Synthesim. It should be identical to the way it was before. And if I increase the decay rate, right, I'm multiplying, so this fraction is bigger, so I'm going to decay sooner. And if I decrease my decay rate, it's going to go, and if the decay rate became 0 in this case, I would stick with the number of grams that I originally started out with. It wouldn't be decaying. I'm not losing it. There's only one outflow to this. So this is structure if you have an exponential decay. It's sort of goal seeking in that the goal is 0 also, and I'll show some goal seeking structure in the next video. Thanks, and I'll see you in the next video.